In this video, we're going to talk about applications of uh, mean and standard deviation for discrete random variable probability distributions. Okay, so here in American Roulette, we have 18 red slots, 18 black slots, and 2 green slots as shown in the picture. And the rules of the game are as follows. If you place a $1 bet on the red, you win $1 if a result of the spin is red, and lose $1 if the result of the spin is not red. So black or green, you lose $1. So placing a bet can be thought of as an experiment whose outcome depends on a chance. We are going to let variable x represent the payoff of such a bet, construct a probability distribution table for variable x, then calculate and interpret the expected value. So what are our outcomes for our variable x? X represents the payoff of a bet. So what is the payoff? Well, you can win $1 or you can lose $1. So those are the possible outcomes. Now let's figure out the probability of each such outcome. We're gonna win if we bet on the red, and we actually roll the red. So we have 18 red slots out of 38 total, right? So that's the probability that we're gonna win. The probability that we're gonna lose, how many losing slots do we have? Well, we have 20 out of 38, right? It's 18 black ones plus 2 green ones. That's gonna be a total of 38. And a total of 20 of 38. Okay, so what's the expected value? Let's see. We have winning dollar multiplied by 18 out of 38, and we have losing dollar multiplied by the probability of 20 out of 38. So that gives us positive 18 out of 38 and negative 20 out of 38. So that's a negative 2 out of 38 or negative 1 out of 19. So what does that mean? It says calculate and interpret. This means that if we play this a game long enough, so sometimes we're going to be winning $1, sometimes we're going to be losing $1, but in the long run, when we calculate how much we lost and how much we won altogether, on average, we're going to lose 1 out of 19 dollars. Again, in the long run, we can only win or lose 1, but in the long run, on average, we're gonna lose 1 out of 19 times. Okay. Next. Okay, I think we're done with this problem. Let's go to the next problem. So the next example reads, Bobbert purchased a new car for $20,000 and wants to purchase an auto insurance policy against totaling his new car. The estimated probability of him totaling his car during the next year is 3.5%. Bobbert and ended up purchasing the policy for a lump sum of $1,000, called the premium, and in exchange, he received an assurance that in case of him totaling the car, he will get paid $20,000. The purchase of an insurance can be thought of an experiment whose outcome depends on a chance. So, what are the possible outcomes for the bobber? Well, he can either total his car or not, right? In this case, what would be the payoff? Well, if he does not total his car, then he's gonna just lose his premium, right? So it's gonna be negative $1,000. But what if he does total his car? Then he's gonna receive $20,000 that he paid, right? But he's gonna also, they're not gonna give him back his premium, so it's minus 10, no, 1,000. So it all in all, it's gonna be $19,000. All right, so now what is the chance of that happening? Well, we have the chance right here. This is the probability of him totaling his car during the next year is 3.5%. So converting it to a decimal, this is what we have. Now, what's the chance that he's not going to total his car? Well, obviously, it's the complement of him totaling the car. So we can figure it out by subtracting the probability that he will total his car from 1. And that gives us 0.965. Okay, so let's figure out the expected value now. So the expected value is going to be negative 1,000 multiplied by the probability plus positive 19,000 multiplied by its probability. And what is it gonna be equal to? So the total result is negative $300. Let's see, what does that mean? Well, that means that from one policy to another, the company either gains $1,000 or loses $9,000 for similar policies. But on average, like over time or with many of such policies, they will, the people are gonna lose or pay to the insurance companies on average $300 per policy. So the insurance company gains $300 on average from selling those policies. Again, when we look at one policy, then they're either gonna gain 1,000 or lose 19,000 from the perspective of the insurance companies. But the probabilities of them losing 19,000 is way smaller than the probability of getting 1,000. So in the end, they end up gaining $300 per policy.